parametric equations and polar coordinates. Today we will start 10.1, which is curve defined by parametric equation. Let me start explaining this way for you. For example, my pen. For example, I have the system of coordinates here, x, y. First, let me define this word for you, plane, right? When I'm using after this the word plane, it doesn't mean airplane. I'm not flying anywhere, right? We are in quarantine. Plane in mathematics here means a surface, means two dimension, x and y. We are talking about some curves that even you cannot define them as a function. For example, I have a particle that's moving on a surface. Let's think about it's a whiteboard and a bug comes in and this bug starts moving on our whiteboard, right? Something like this. This bug starts moving this way. Going here, 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 because they want to go everywhere, right? You cannot track them where they want to go. If I name this curve, for example, curve C, can I define C as a function? SC is a function. Is this curve is representing a function? Yes, no.
Yeah.
Yeah. Do a vertical line test. Is this a function?
It's not continuous.
If you do a vertical line test like this, is this now a function?
No.
No. You see, even it's not a function. How to explain these curves or how to even sketch them, how to write an equation for them, we are talking right now about plane curves. The first thing that you want to learn is what is plane curve. Really bad handwriting. I will give you a definition for a plane curve. The motion of an object or particle in a plane is plane curve. You see, I had an object here. I'll give you the example of a bug. This bug is moving on the whiteboard. I don't know where. They don't respect mathematics. They can go anywhere, right? Even we don't know the coordinates. The motion, it means the movement of this object or particle in a plane, we call it a plane curve. Correct? First thing to remember. Now, there are some problems that we cannot explain them as a function of x to y or a function of y to x. What are those problems? Problems. We are talking about problems. We cannot, number one, we can't define a plane curve when I touch the button, it goes like this, a plane curve like normal function. What does it mean? It means I doesn't have this coordinates. X, Y. I cannot define that. When it's X, how much is Y? Problem number 2. Many of them, you cannot say it's a function of X based on Y or it's a function of Y based on X. I don't know. Look at this curve above. I don't know. It's a function of X or on Y or Y on X. And on problem number 3, there is no direction. I told you, if it's a but doesn't respect mathematics, there is no proper direction for me. Now, how to deal with these parametric curves? That's why the idea of parametric equations comes in. Now, if I put this for you, parametric equations, it helps us a lot to talk about those kind of curves. Look at again my graph. For example, it was something like this. I'll redraw something like a crazy curve for you, right? Like this. For example, this is point C. This point doesn't have properly a coordinates of x, y. But my x can be a function of time, another variable, another third variable, maybe t, and my y can be a function of t. It means I can write my x equals f of t, and my y equals also f of t. For example, in this movement, if it's a motion, t is time. When the particle is moving from here to here, it needs some time. Then x is a function of t. And also, y has a coordinates. It means y is a function of t. But t is not always representing time. Sometimes t is representing an angle. I will do a lot of examples for you. You will see it's just a third function. It's a third variable. And you can define x as a f of t, y as a f of t. It means you can easily find the coordinates of x, y, correct? We call x equal f of t and y equal f of t parametric equations. And we call t parameter. Your t is your parameter, correct? These two equations, we call them parametric equations or equation, correct? Here you see x varies to the t, and same time y varies to the t. Then my coordinates of x, y varies actually as a f of t, and let me name this one g to bring a little bit different, and g of t, y, g of t. What does it mean? This coordinates or this parametric equations, they helps you actually to find the exact coordinates of the point and can graph. Even sometimes based on these parametric equations, we can write the actual equation for the function x in terms of y or y as a function of x. X as a function of y or y as a function of x. But right now, what we get, we have x as a function of t and y as a function of t. This way, if I explain to you, maybe it gets more difficult and difficult. Let's do an example. And an example, I can explain it very well and easily for you. What does it mean? What is parametric equation? Example number 1 of your book says sketch and identify the curve defined by the parametric equations. Two parametric equations is given to you. x equals t squared minus 2t, and y equals t plus 1. This one is a parametric equation. Why it's a parametric equation? Because f is a function of a third variable t. Is this a parametric function? Yes, because y is a function of a third variable t. Then we can call these two a parametric equation. Now they are asking you to sketch this curve. How to sketch this curve? Always make a table like this. I will put here t, here x, here y, here maybe xy as an order pair. Choose some values for your t, because if you want to find the value of x, you have to choose value for t. For example, start with 2, 1, 0, -1, -2. Let's plug in these values in both parametric equations. When x is 2, if I plug in here 2, I have x equals t squared. It means 2 squared minus 2 times 2. It means x equals 4 minus 4, which gives me what? 0. Same time, let's plug 2 and y. If I plug 2 here, it will be y equals 2 plus 1, which gives you what? 3. You see, I got an order pair, x0, y3. Same way, if I plug in 1 here, 1 square is 1. 1 times -2 gives you -2. 1 minus 2 gives you -1. And if I plug in here 1, 1 plus 1 gives me 2. That means I'll get another order pair, -1 and 2. Same way, if I plug in 0, this part totally becomes 0. X becomes 0, y becomes 1. It means I'll get another order pair, 0 and 1. If I plug in -1, -1 square is 1. -1 times -2 gives you 2. What is 1 minus 1 plus 2? 3. And if I plug in here -1, -1 plus 1 gives me 0. It means I'll get another order pair, 3 and 0. And last, if I plug in here -2 square gives me 4, and -2 times -2 gives me +4. 4 plus 4 means 8. How much is y? -2 plus 1 gives you -1. It means you get another point, 8 and -1. Any question on this step?
No.
Clear for everyone? They
Yes.
give you a parametric equation. First thing to do is choose values for your t, for your third variable, plug in both parametric equations and get the value of x and y. Now, using these points, actually I can graph, right? Let's start with the points. x0, y3, for example, 1, 2, 3. x0, y3 is this point. -1 and 2, x -1, y2, this point. 0 and 1, x0, y1. x0, y1, here, this point. x3, y0, x3, 1, 2, 3, y0, and x8, for example, if it's 8, y -1, this point. Also, if I plug in more points, I'll get more points on this side, and easily I can graph a smooth curve. Please graph a smooth curve, not like my curve. I'm using an electric pen. It's really difficult to graph a smooth curve here. You see, you end up with a smooth curve. Which kind of curve is this? Do you see it in algebra before, this kind of curve?
Parabola.
Hyperbola, right? It's a parabola. Oh, it means I can write an equation for this. Sometimes it's easy to use the third variable to find these points, even the second way. Let me show you. The second way, look at our parametric equations. I have x equals t squared minus 2t, and I have y equals t plus 1. Can I solve this equation, y equal t plus 1 for t? Is it possible to solve it for t? Can I write t equals y minus 1? Yes?
Yeah.
Now,
Yeah.
taking this value, can I substitute here? Then I'll get x equals y minus 1 squared minus 2 times y minus 1. Let's simplify this equation. Then x equals y squared minus 2y plus 1 minus 2y plus 2. It means x equals y squared. Negative 2y gives me negative 4y. Positive 1, positive 2, positive 3. Is this the equation of a parabola? You saw it before in algebra. Equation of a parabola that opens to the right. You see it?
Yeah.
Even if you use values for y, even you end up with the same values that we have here in our table, and the graph will be the same. Like around 60% of the time you can write an equation out of the given parametric equations. Sometimes maybe we cannot write another algebraic equation, a function of x based on y in respect to y. Sometimes we can do that. Sometimes for some problems, we cannot create a function like this. This is the whole idea about, or the beginning idea about the parametric equations. Any question on this example? Yes, no?
No.
Everyone? Can I move to next example?
Sure.
Yes.
I will do another example that's not in your book, then I'll go to example number 2 of your book. But before that, let me do another example and I'll explain something also extra here. Example number 2. X equals t squared minus 4, y equals 2t, but they give you this restriction. T should be less than equal 4, greater equal 0. In example number 1, there was no restriction for t. It means the domain of t for problem number 1, the domain for t was from negative infinity to positive infinity. But here, sometimes or most of the time, they give you a restriction also for t. This one means restriction in the domain of the third variable. In some books, even they call that restriction or that domain I. The domain I has a restriction. What is the restriction? What is the domain here? The domain starts bracket 0 to comma 4. That's the domain. These are the values that you can use in your table, not more than this. In problem number 1, I was allowed to use a lot of points, but here only from 0 to 4, correct? Let's draw our table. Method is the same. T, X, Y, here XY. From where I should start in my table, which value you want to put? Where is the starting point in your domain? What is the starting point in your domain?
0.
0. Start from 0 and go to 4. For example, 0, 1, 2, 3. Let's put 4 here. And 4. When you plug T0, make sure to plug in both parametric equations and calculate both values, correct? Plug in 0 and the X gives you -4. Plug in 0 and the Y gives you what? 0. It means your first point is -4, 0. Plug in 1 and the first equation gives you -3. Plug in 1 and the second equation gives you 2. It means your second point is -3, 2. Plug in 2 and the first equation gives you 0. Plug in 2 and the second equation is again what? Plug in 2 and the first equation 0 and the second equation gives you what? 4. It means 0, 4 is another point. Plug in 3 in the first equation. 3 squared is 9. 9 minus 4 gives you 5. Plug in 3 in the second equation gives you 6. That means your next point is 5, 6. Plug in 4 in the first equation gives you 16. 16 minus 4 gives you 12. And plug in 4 in the second equation gives you 8. It means your next point is 12 and 8. Let's graph it. Hopefully, if I can graph. What is the first point that I have to start? What is the first point that I have to start? -4 and what? 0. Remember, when you have a restriction, when your domain is restricted, it means the graph starts from somewhere and moves and stops somewhere, right? The starting point, let me write this way, the starting point, we call it initial point. Remember, your starting point means what? Your initial point, which is in this case, in this problem, -4 and 0. 1, 2, 3, -4 and 0. This is my starting point. Then I have -3 and 2. X -3, Y 2, somewhere here. Then I have 0 and 4. 0, 4, somewhere here. Then I have 5 and 6. 1, 2, 3, 4, 5, and 6 somewhere here. And last one, I have 12 and maybe 8 somewhere here. If I connect these points like this, it starts from this point, which is my initial point, and it goes to this point, which is 12 and 8, which is the end point, right? And we call the end point the terminal point. Initial point and goes to terminal point. Those of you that you had a trigonometry class, which none of you, because we don't have trigonometry class on MSGC, but at least you studied trigonometry and pre-calculus. Your professor on that time talks about the initial and the terminal when you are dealing with the angle. Same idea. The starting point, initial point, ending point, terminal point. Remember, I start from initial and I am moving this way. I am moving this way. It means direction gets involved. My direction is this. Starting from 0, going to 8. That is the direction of your curve. Any question up to here? I introduced two new things for you, initial point and terminal point. Any question? And also direction.
No, thank you.
Okay. Now can we make a simple function, a function of x in terms of y out of these two parametric equations? Let's try, let's see if we can do that. I have x equals t squared minus 4, and I have y equals 2t. If I solve this equation for y, for t equals y over 2. Let's plug in this y over 2 here in x. Then you can write x equals y over 2 all squared minus 4. It means x equals y squared over 4 minus 4, a function of x in respect to y. Easy, difficult?
Easy.
Easy.
Yeah, it's straightforward.
Math is easy.
Difficult.
Let's try this. Look at this example. Let's bring some trigonometry also. X equals cosine t and y equals sine t, and t is restricted between less than equal 2 pi, greater equals 0. I have a restriction again for t. Do you want to try for a few minutes? Or you want me first set it for you, then you want to try?
Let's just try for a few minutes.
Your t, your x, your y, here order pair of xy. Tell me, what is the starting point? What is your initial point?
0.
0. You start from, because your domain is here from 0 to where? To 2 pi. You start from 0. What is next point? The easy points. For example, 0, then pi, use pi over 2, then use pi, then use 3 pi over 2, and maybe one more, use 2 pi. Plug in, give me values. When you plug in 0 and cosine t, what is cosine of 0?
1.
Sine of 0?
0.
You see, you got a point, 1, 0. What is cosine of pi over 2?
0.
Sine of pi over 2?
1.
What is cosine of pi?
-1.
Sine of pi?
0.
What is cosine of 3 pi over 2?
0.
0.
0. Sine of 3 pi over 2,
-1.
negative 1, right? I'm looking to the unit circle. This is unit circle, guys, right? Cosine of 2 pi
1 and 0.
and sine of 2 pi 0, 1,
Yeah, we
0.
1 and 0 again.
Can you graph this for me?
Yeah,
Connect these points and see what's up.
it's a circle again.
Wow, it's a circle, huh? 1, 0, 0, 1, negative 1, 0, 0, negative 1. And if I connect, wow, really bad. Oh, I'm trying to control my hand on the path. That will be a nice circle, not this bad, right? Right now, my circle is like our Earth because coronavirus is hitting everywhere. This is our situation now, correct? What was your initial point? Where was the initial point? Here, right? Which was 1 and 0. This is your initial point. And the direction, this way. You start from 0, 1, you go all the way, and you come this way, back to your end point, which your end point is also, or the terminal point is also 1 and 0. You see, terminal point, initial point. Easy, difficult.
Easy.
What is the equation in algebraic way for this? What is the equation of a circle? A unit circle, center at 0, 0.
Plus y squared equals
X squared
Yeah.
plus y squared equals 1, right? Because you see, cosine squared t plus sine squared t also gives you 1. Then immediately you can write an algebraic function, x squared plus y squared equal what? 1. Is t is time in this example? Is t representing time in this example?
No.
No. Actually, your t is representing an angle here for you, right? T is the angle. You see, t is the angle. 0, pi over 2, pi, 3 pi over 2, 2 pi. Your t is actually representing an angle. It's not necessary that your t all the time represents a time. It can represent also an angle, right? Question. Yes, no.
No.
No, no.
Easy, difficult.
Simple.
It's easy, huh?
Yeah, well, straightforward.
Yeah. Okay, that was all about 10.1.
Sorry,
I
Professor,
give
I
you
have a question.
please.
I had a difficult time getting onto Zoom for the first like 7 minutes, so I'm sure you don't want to have to repeat yourself, but was anything discussed at the beginning of the lecture that was important for us to know?
Yeah, same here for me.
At the
the
beginning,
curve.
I didn't discuss anything. I just start with that example parametric equation. I don't know why everyone has today a problem to get in.
Everyone actually, from what I heard from the physics teacher, and sometimes from Canvas was notifying us too. Zoom has just been having a lot of errors lately, especially today and
We
yesterday.
have a lot of errors. We have a lot of errors in Zoom, but this is the only tool right now, right? This is the only tool that we are using, and it's an
Yeah.
official tool because we have it in Canvas. That's why I'm going for this. Hopefully, usually try to get into class a little bit earlier if you have time. If something happens, you have a little bit of time to get in, correct?
Well, I kept trying and it gave me an error, like a little error black box every single time I tried, probably 15 times for about 7 minutes. So I think it was just Canvas
Wow.
it was through Confer Canvas or whatever.
Yeah.
So it eventually let me in, but my point was is just I didn't want to, if there's something, I noticed you recorded as I got in, so I didn't want to make sure I didn't miss anything prior to that.
I had the same problem. You had already started 5 minutes. You were 5 minutes in by the
Yeah.
time I
I
finally was
have the
able to get in.
recording from the beginning. Okay, don't worry. I have the recording because as soon as I start the lecture, I push the button of recording. And after I close this meeting, sometimes they send me really fast the link. If they send the link of the video, I'll post it immediately for you to can cover if you kind of missed something from the beginning, okay?
Thank you.
Also, you saw at the beginning, there were just only 7 people online. Did you saw your grades? Quiz 2?
Yeah.
Something magic happened, right?
Yes.
Yeah, it happened once in my whole life. I never did this before. I told your friends also. For the first time in my career, I did a curve for you guys because it's a kind of special time. Put your notes in your diary that 2020 was a really bad year, that we were quarantined, and one of the magics that happened, we had a professor that he did it for the first time in his life, a curve. I did a curve for you to help you to kind of pump your grade up. It happened only once, and it's not going to happen for test 3, right? Use this opportunity and study a little bit more for test 3. There is no need for me to post again the test for you because my plan was to give you another chance. Then I think like, okay, soon next week, maybe they have another test and finals are really close. There is no time to redo the test. That's why I did that curve for you. At the same time, quiz number 3, maybe you already saw it's open for you. You have 2 more days to finish your quiz. Work as a group with each other, but you have to come back to Canvas, and as an individual, you have to click on the right answers, correct? But you are allowed to work as a group. Do your quiz 3 also. Also, I have 1 test paper that there is no name on it. Those of you that you see, if it's this paper belong to you, send me an email, please. Send me your name. Because if you see a 0 in your score, it means that paper is belong to you. Send me an email, right? I have a paper with no name. Any other question regarding the grades?
Will quiz 3 be covering chapter 9?
Yes, quiz 3 is almost chapter 9. 5 problems.
Okay.
Where can I find the homework for the first few sections?
You will see it today. Give me some time. I'm dealing with a lot of issues. You will see it today. At least I could transfer your grades that I promised like since 20 days and I couldn't transfer. It takes a lot of time to transfer from one system to another one. I did it finally. Happy with your grades, guys? Did you see your grades?
Yes,
Yes.
thank you.
Even with that, yeah, even like aside from the curved test, I was doing better in this class than I thought I was.
Yeah, now when you are satisfied with your test 1 and test 2, if you have an A or B and you are satisfied with your grade, there is no need to take test 3. But if you want to take it because you are close to final, you need practice. Anyway, I'm dropping the lowest score. Then take it. If you make more grades, it's good for you. If not, I'll keep those, but it's up to you. Those of you that you have lower grades, try your hard for test 3 as your last chance. Try really hard for test 3. Any other question for me?
Do you have an idea based on what you know you're going to be covering when test 3 might be?
Test 3 will be mainly chapter 9, the sections that we went over, and also up to 10.3. Today I went over 10.1. It means I do 2 more lectures, 10.2 and 10.3. Then I'll send you a study guide. Then we take your test 3, which is chapter 9 and 10.1 to 10.3.
Okay, thank you.
You're welcome. You are welcome. Actually, Janelle, you did a really good score. How much was the score? You were 90, and I had students with 100 also. Only I think 1 or 2 students, they got a full 100. To be honest, I didn't announce the 100 because they were also part of the curve, right? But it means their grade was really high.
Wait, so if you got 100, does that mean you still got an A on the real test?
Yeah, it was on a real, it was almost an A because I did a curve. When I do a curve, I do for it, right?
All right, bet. Thank you.
Yeah, don't wait for another curve, okay? It happened once by mistake, maybe. Okay, guys, have a now I'll end the meeting.
All right.
Take it easy,
goodbye.
Professor.
Be safe.